AP Calculus, section 7.2, page 4. Okay, we are going to be finding the area enclosed by x equals y squared and x equals 9. There are two ways to solve this problem, and I'm going to take you through both ways. And then sometimes one way is easier than another. Sorry, the next page was bleeding through. I saw it associated. All right, so firstly, we need to graph this. Well, we're going to need to solve for y first, which is going to give us y equals plus or minus the square root of x. So, graph here's y equals positive square root of x. Then we have y equals negative square root of x. That's going to be this piece down here. And x equals 9 right there. So the region that we want then is this shape right in here. All right, so following the same thing that we've been doing, looking at top minus bottom, and the top function here is this square root of x minus the bottom function. The bottom one is this blue one down here, which is negative square root of x. Dx bounds from where we start area, so at 0 to where we stop area is out here at 9, so your bounds are going to be 0 to 9. And looking at this square root of x minus a negative square root of x, that is 2 square root of x. Which we can pull that 2 out. All right, now, if you can see this and go right to this line, that's perfectly fine. If you notice the symmetry in this graph, we could just find the area underneath y equals the square root of x and then double it to get the bottom half. That's what this says. If you see that, that's perfectly fine just to jump right to here. Plugging on through on this one, let's see, we're going to have to change this to be x to the half first. Then do an antiderivative. That's going to give us 2/3 x to the 3/2, evaluating from 0 to 9. I'm going to clean this up first. Make this 4/3 x to the 3/2 from 0 to 9, which will be 4/3 times 9 to the 3/2 minus 4/3 times 0. All right, this piece clearly 0. This one, remember, power over root. So do the root part first. So square root of 9, 3 cubed, 27. So we have 4/3 times 27. We can divide out by 3 here. That gives us 4 times 9, or 36. Okay? Now, there's another way to do this. And I do want to look at this graph first. Bigger. Here's y equals square root of x. Here was y equals negative square root of x. And here's that line, x equals 9. What was this whole area? 36. But if I turn it this way, it's still 36. But now what's the top function? The top function would be this line, and the bottom function would be this parabola. So we can shift the way that we look at this, and instead of doing top minus bottom, when we put it back the way that it was originally, we have right side minus left side. So we can shift the way that we're looking at finding that area. And I'm just going to redraw this very quickly. Oh, I guess I drew that part a little bit better. That's okay. Same area, but again, because we're rotating and how we're looking at this, we rotate this figure 90 degrees, counterclockwise. The top function is that line, and the bottom function is the parabola. And if we put it back the way that it is situated originally, it's not top minus bottom anymore, but it's right minus left. So we could calculate this by doing right minus left. Now if we're doing right minus left, it's not dx's anymore, that's dy's. And the right function is the line minus the parabola, dy's. Okay, the line is 9 minus the parabola. Now, because we have dy's in here, we want to put y's in this equation, which means I have to have been solved for x. So we have 9 minus y squared dy. All right, now bounds. We're going from bottom to top now because we want points of intersection from bottom to top. This point right out here was at 9, negative 3. This point was at 9, 3. So your bounds, y bounds, then this time because we're y, is negative 3 to 3. Anti-differentiate. We have 9y minus a third y cubed, evaluating from negative 3 to 3. 9 times 3 minus a third times 3 cubed minus 9 times a negative 3. Boy, watch the signs on this one. There's lots of 3's, lots of negatives. Let's see, there's 27 minus 1/3 of 27, 9. So that piece is 18. Over here we have negative 27. There's negative 27 times a negative third, positive 9. So we have 18 minus a negative 18, which is 36. Oh my goodness, that's wonderful. Aren't we supposed to get the same answer? The beautiful thing about math, right, is no matter which way you do the problem, as long as you don't make a mistake and everything is mathematically valid, you get the same answer either way. So 36 and 36. I know this is uncomfortable. It's because it's new for you. We will spend more time doing this, so don't panic too much. A couple of things that we just need to iron out here. Remember, this area stuff all goes back to rectangles. So when we first started doing these, we are stacking rectangles left to right. So these are the rectangles stacking this way, and we are summing rectangles. These are called elements of area. rectangle is your elements of area. The elements of area, or rectangles, are perpendicular to the x-axis. They're stacked this way. But perpendicular to the x-axis is also parallel to the y-axis. That's this situation. Parallel to the y-axis is when you're finding area, we will do top function minus bottom dx, and your bounds are the left x to the right side x. These guys are rectangles stacked this way. These are called elements of area that are perpendicular to the y-axis. But perpendicular to the y-axis is parallel to the x-axis. Oops, can't see it. There we go. This setup is area. Instead of going top minus bottom, though, we go right minus left. And right minus left is dy. And you are going from the bottom y value to the top y value. I know this is iffy, or I think it's probably iffy for you. That's all right. Listen to this video again, and then join me on page 5, and hopefully we can clean up some of your questions.